Good morning, everyone. Today we are going to discuss other algorithm, that is k nearest neighbors. That is simply we can say that KNN algorithm. KNN is very simple classification and regression algorithm. In case of classification, new data points get classified in a particular class. But whereas coming to the in case of regression, new data gets labeled based on the average value of k nearest neighbor. So what is this new data points or average value of k? We'll discuss further. And it is also called as lazy learner. Why? Because it doesn't learn much from the training data. And KNN is a supervised learning algorithm. Why? Because it can be used for both classification and regression. And here one more important point regarding KNN is the Euclidean distance. So what is this Euclidean distance and in what way it helps this KNN algorithm? We'll see. So what is this KNN algorithm? K nearest neighbors is one of the simplest supervised machine learning algorithm mostly used for the classification. That means it classifies a data point based on how its neighbors are classified. So as the name itself indicates its neighbors. So according to its neighbors calculation, it is going to give us the data point. And KNN stores all available classes and classifies new cases based on a similarity measure. Suppose here, just see here we have red wine glasses and white wine glasses. And when a new data point occurs, first it is going to find out the distance between to its nearest neighbors, and whichever is having the highest majority votes, that it is going to be classified into that class label. So K equal to 5 here. So K in this KNN is a parameter that refers to the number of nearest neighbors to include in the majority voting process. So generally we are going to take it K equal to either 3 or 7 or 5. Only odd numbers we are going to take, and it is a parameters. Why? Because it gives us the output label. And when we have taken K equal to 5, a data point, the given data point is classified by majority votes from its five nearest neighbors. So when you see here, we have taken K equal to 5. So it is going to calculate the distance between the data point to its nearest 5 neighbors. And from this diagram, we can see that majority are belonging to red wine and only one is belonging to the white wine. So this particular new data point, we can classify it belongs to the red wine. In this way, it is KNN algorithm classifies the class label into 0 or 1. Then the here important point regarding this KNN is how do we choose the value of K? So KNN algorithm is based on feature similarity, and choosing this right value of K is this process. Generally, we call it as a parameter tuning, and it is important for better accuracy. So see here there is a new data point, and we already have 3 data point, and we have taken K equal to 3. So when we see this majority, when we take K equal to 3, the majority says that it is a red color. So we can classify that new data point is belonging to this particular class. The same example, if we take K equal to 7, K equal to 7, then when we see this process, here when you see this, when we take K equal to 7, the majority says that it belongs to a triangle. So in this case, the new data point, we are going to classify it as a triangle. So choosing the right value is the very important thing in KNN algorithm. Why? Because it gives us the better accuracy. Now, you may get a doubt. So how to classify this? When we take K equal to 3, it is giving us red as answer, and when we change it to K equal to 7, it is giving a triangle as answer. So which K we should use? That is a very important factor in KNN algorithm. So how do we choose the factor K? So to choose the value of a K, the very first thing is we are going to take the square root of n. So we are going to take the square root of n, and where n is the total number of data points. And an odd value of k is selected. Remember, whenever we take the k, it should be an odd number. This is one more important point, and the other one is a square root of n. These are the two ways to select to choose a value of k. Is going to select to avoid confusion between two classes of data. For that reason, we are going to take the odd value of k. Then, when we can use this KNN algorithm? So, we can use KNN when only data is labeled. This is the first point. Data should be labeled, then only we can use the KNN. And data is noise free. So when you take this as a sample data set, so here we can say that the class underweight normal, okay, this belongs to the classes, but when you take these three, now we can say that it is a noisy data. So in that cases, KNN algorithm doesn't work. And when we are choosing this KNN, data set should be small, because as KNN is a lazy learner, it doesn't learn a discriminative function from the training set. So we should have a small data set, then only KNN algorithm gives us the accurate results. Then how does this KNN algorithm works? So let us explain this KNN algorithm with one example. Let us consider one data set here. We have two variables, weight and height, both in one in centimeters and one in kgs. And each point, each as per weight and height of a particular person, he belongs to either normal, underweight. So this is a sample data set given. Now, so on the basis of the given data, now we have to classify this particular new data where a person is having 57 kgs and 170 centimeters, whether he belongs to normal class or underweight. We have to calculate this, or we have to classify this one using the KNN algorithm. Now, let us see how this KNN algorithm classifies this particular given data into one of the class label. To find, first very important thing is we are going to find the nearest neighbors. For that we have to calculate the Euclidean distance. Students, maybe you already know in mathematics we have different types of finding distance, that is Minkowski distance, Manhattan distance, Euclidean distance. So the default method for KNN algorithm is the Euclidean distance. So now what is this Euclidean distance? Let us see first how we are going to calculate the Euclidean distance between two data points. So according to the Euclidean distance formula, the distance between 2 points, within a given plane, which is two coordinates xy and ab, it is given by square root of x minus a whole square plus y minus b whole square. This is what the formula for finding out the Euclidean distance between the two coordinates xy and a and b. So under square root. So we are going to make use of this Euclidean distance to find the k nearest neighbors. Now let's calculate it to understand clearly. See, as per the given sample data set, I have plotted these data points, and this is the new data point. Now this unknown data point, we have to classify whether it belongs to this class or this class by finding out the Euclidean distance between the data point to the existing data points. Now, coming to this distance d1, okay, here. So this is the Euclidean distance. As per this data set, just see this here data set. We have the first one 51, 167. 51 and 167. This is the existing in a data set. And the question here they are asking is about 57, 170 centimeters. 57, 170 centimeters. Now, first we need to find out the distance from the unknown data point to the given data point. So let us name it as distance d1 here. So that is given by 170 is the one we have to find out. So 170 minus 167 whole square plus 57 minus 51 whole square. We are going to get some value 6.7. Similarly, let us find out the distance between this unknown data point to here, that is, let us name it as d2, and from here to here let us point it as d3. Means as per the data set we are calculating. So see here 182, 62. So we'll go back to our data set. So here you can see that 182 to 62, 176 to 69. likewise, we are going to calculate the distance from unknown to all the distances. So after calculating, so these are the values I got from unknown data point to the given data points. So I got for first one 6.7, then 13, 32, 13.4. Likewise, I got these values. Now, the question is, so we have calculated the Euclid distance of unknown data point from all the points. This is what and where this x1, y1 equal to 57, 170, which is we have to find out. Then which class we have to classify, which class it belongs. So now see here, let us calculate nearest neighbor. Let us take the value of k as 3. Now, when we have taken the value of k equal to 3, so the nearest, which is having the less, just see in this Euclidean distance, the very first least distance is we are having 1.4. That we have selected. Then after 1.4, we have 2, then 3. So k, when we have taken k equal to 3, so these 3 classes results in normal. So we can conclude that the new class belongs to the normal weight. This is how the KNN algorithm works. So the majority neighbors are pointing towards normal. So as per the KNN algorithm, the class should be normal. Suppose you may get a doubt that if you take k equal to 5, then you can see, then you can go for other, next one is 4.1 and the next one is 6.7. So when you take k equal to 5 also, the majority is normal only. So even we can conclude that the new class belongs to the normal class. In this way, by changing the value of k, only the odd numbers taking, we are going to find out the new class belongs to which class. So this is what once again repeating, this is one of the simplest machine learning algorithm based on supervised learning technique. And it is used for classification as well as regression, but mostly used for the classification problems. That is one important point. How does KNN work is, first we are going to select the number k of the neighbors, and just we are going to calculate the Euclidean distance of k number of neighbors. And we are going to take the nearest neighbors as per the calculated Euclidean distance. And among these key neighbors, count the number of data points in each category and assign the new data points to the category for which the number of neighbor is maximum. And then our model is ready. So these are some of the steps. How does this KNN works? So this is the Euclidean distance. I already told you the Euclidean distance, how we are going to find out the distance between two coordinates in a given plane. We are going to find out like this. And the same example. So how we are going to take this k nearest neighbors. And these are the different metrics for finding out the distance between the data feature values and the new test inputs, Minkowski, Euclidean, and Manhattan. But the default method is the Euclidean distance. So is which is the most widely used distance measure because to calculate the distance between test samples and the trained data values. Straight line equation we are going to find out. So this is the same different examples of how we are going to represent a KNN algorithm. So the same thing. So here the very important point is how to choose the k value. I already told you. We are going to take this k value in the count of the nearest neighbors, and we have to compute the distances between the test points and the trained label points. And updating distance metrics with every iteration is computationally expensive actually. That's why we call this KNN is a lazy learning algorithm. It takes much time. How selecting an optimal k value is the biggest thing, and it's a challenging for a developer who is implementing this KNN. Choosing the small value of k may leads to unstable decision boundaries. And if you take the higher values may leads to the overfitting. So we should, choosing the k value should have a minimum error rate and it should give the accurate result. So in that way, we have to choose the k value. So choosing optimal k value is the biggest point in choosing the KNN algorithm. And see here, if you k equal to 3, it belongs to red. And if you take k equal to 9, it belongs to green. So that's why we have uh, important thing that what is the choosing k value. And I already told you that choosing the right value of k is called as the parameter tuning. And if you take the small k, you'll have a low bias, high variance, which are the two different challenges like overfitting and underfitting in machine learning. These are also challenges, low bias and high variance. And if you take the large k, there will be high bias and low variance. So we should manage these two things while you are choosing the k value. So here is one example. Just pause for a minute and make a note of this, the given data set. And then you have to predict a particular person is having height 161 centimeters and weight 61 kgs. So now for this height, tell me either you can choose the value of k equal to 3, you will choose, or k equal to 5. Okay. And tell me which to which size it will fit, either medium size or large size. So the same earlier example, how we have found that step 1, calculating the Euclidean distance between the new data point and existing data points. And if you take 3, nearest to 3 neighbors, which it gives majority voting, that we are going to take. And if you k equal to 5, which majority voting it gives, you take in that way. And predict the results. So this is how the KNN algorithm works. And this is another example, iris data set. This is the given sample data, and this is the one new instance. Until find out the new data point belongs to which class by using the KNN algorithm. Thank you.